1984. 127 sounding rockets, 13 scientific satellites, 5 application satellites, the qualification and start of operational flights by the Ariane launcher, the first flight of Spacelab, and major technological achievements. These are the fruits of 20 years of European cooperation in space. When the first Soviet and American artificial satellites were launched, European scientists realized the importance of space as a vast field for experiment and a new means of communication. Leading figures in the world of science who'd helped to set up CERN, the European Nuclear Research Organization, met together. The outcome, at the end of 1960, was the convening of an intergovernmental conference at Merin, near Geneva. This was to lead to the creation of ESRO. At the same time, a number of European governments and Australia offered to work together on building a 3-stage satellite launcher. The diplomatic conference that met in 1961 led to the setting up of ELDO. Activities began in 1964. While the Europa launcher was to meet with substantial difficulties, space research marked up successes from the very beginning. Sounding rockets were fired from Sardinia, Greece, and Norway, and from Sweden too, where, close to the Arctic Circle, a European launch range was set up. Technical establishments were created to cope with the design, preparation, and integration of scientific satellites. ESTEC, the European Space Research and Technology Center, was built in the Netherlands and equipped with integration and test buildings. ESOC, the European Space Operations Center, was built in Germany and has become the biggest computing center in Europe. This is where the orbits of satellites are plotted and where data coming from scientific and weather satellites are received and processed. Linked to ESOC are tracking stations like those at Redu in Belgium, Michelstadt in Germany, Fairbanks in Alaska, Fucino in Italy, and Villafranca in Spain. ESRIN, the European Space Research Institute at Frascati outside Rome, brought together researchers in space physics. Later, the ESRIN premises were to be used for different purposes, housing the IRS, Information Retrieval Service, a whole scientific and technical library on computer, and the EarthNet program. 1968, only 4 years after activities began, 3 scientific satellites were already in orbit. ESRO-2 for studying cosmic rays and solar X-rays. ESRO-1A for studying the polar ionosphere and auroral phenomena. And HAOS-1 for studying the solar wind and solar particles. These were the first successful steps that made Europe a full member of the Space Club. 1969, ESRO-1B was launched to carry on the research begun with ESRO-1A. 1972, 3 satellites were put in orbit. HAOS-2 for studying the magnetosphere and interplanetary medium. TD-1A, the first European astronomy satellite, and ESRO-4 for studying the ionosphere and solar particles. The field of research was widening and the weight of spacecraft increasing. TD-1A weighed half a ton. The scientific community and Europe as a whole had acquired a new technological ability. The scientific satellites that were to follow: COS-B in 1975, JOS-1 and IC-2 in 1977. IU and JOS-2 in 1978. Exosat in 1983 have confirmed Europe's mastery of these skills. JOS-1 and JOS-2 supplemented knowledge of the magnetosphere. And beyond this relatively thin envelope round the Earth, satellites were entering a new field of astronomy, the ultraviolet. IUE, a satellite for exploring the ultraviolet, gave the scientists new maps of the stars. COSB, with its gamma-ray observations, made important discoveries possible. And Exosat is exploring the hitherto scarcely known field of X-ray sources. From the time of these first successes and through the various difficulties experienced in developing the European launcher, it was obvious that if Europe was to be really independent, it needed to aim determinedly at undertaking applications programs and to have its own launcher for heavy satellites. Europe needed, too, to take part in manned spaceflight. And finally, Europe needed to coordinate all its activities within a single organization. This was to be ESA. There were 4 crucial years. 1971 saw the startup of the OTS telecommunications program. 1973, the startup of the Ariane European Launcher Program. 1974, the startup of the Spacelab program for a reusable manned space laboratory. 1975 brought the setting up of ESA, the European Space Agency. A first Earth observation satellite was built, Meteosat. The European weather satellite was launched on the 23rd of November 1977, forming part of the Global Atmospheric Research Program. A geostationary satellite, Meteosat provides half-hourly images of the Earth and its cloud cover in the visible, thermal, infrared, and water vapor ranges. At the same time, OTS was being built. This is an orbital test satellite for telecommunications, geostationary and stabilized in 3 axes. Its solar panels were deployed soon after its launch on the 11th of May 1976 for a working life of more than 5 years. All these launches were still being made using American rockets. But on the 24th of December 1979, the monopoly was broken when for the first time Ariane rose into the sky above French Guyana, using both tried and proven techniques and a very advanced cryogenic engine for its 3rd stage. Three of the 4 test firings were successful. And on the 19th of June 1981, Ariane placed ESA's Meteosat 2 satellite in orbit together with India's Apple communications satellite. On December 19, 1981, Ariane launched the Marex-A maritime communications satellite, the first operational satellite destined for the Inmarsat worldwide marine navigation system. The 6th Ariane launch carried another communications satellite, ECS-1, the first of 5 satellites in a European satellite telecommunications system managed, as from November 1983, by the international organization Eutelsat. American Intelsat 5 satellites, the biggest communications satellites launched so far, were put into orbit by Ariane on the 18th of October 1983 and March the 4th, 1984. The marketing of the European launcher now handled by an international company, Ariane Space, can begin while ESA brings in the more powerful Ariane 2, 3, and 4 versions. These will be able to put up to 4 tons into geostationary transfer orbit. Man in Space 2 has been included in Europe's program since 1974 in Spacelab, a reusable space laboratory that is Europe's contribution to NASA's space transportation system. This laboratory is made up of pressurized modules in which engineers and scientists can carry out a program of onboard experiments, and platforms carrying instruments that have to be directly exposed to the space vacuum and radiation. Spacelab is carried into orbit by the Space Shuttle. The first Spacelab mission lifted off on the 28th of November 1983. Spacelab was carrying about 70 European and American experiments with some Japanese involvement. For this mission, the crew numbered 6 and included a European, the physicist Ulf Merbold. Initially planned for 9 days, the mission went so well that it was extended to 10. As a follow-up to the Spacelab program, work is starting on developing Eureka, a European retrievable instrument carrier that will stay in orbit for 6 months. This is a kind of unmanned automatic laboratory and workshop, the precursor of large-scale orbital infrastructures that will themselves be midway stages between Spacelab and the space station. A number of programs are going on in parallel. The ISPM and Hipparcos scientific satellites and the Space Telescope are being prepared for launch between 1986 and 1988. The microgravity program is proceeding. After the setting up of the EarthNet network for distributing Earth resources images, work is going on ERS-1, the first remote sensing satellite. The Meteosat operational program is beginning. A recoverable launcher and European participation in the American space station are being studied. Giotto is undergoing final tests and preparation for launch in July 1985. It is essential that this satellite is on time for its rendezvous with Halley's Comet on the 13th of March 1986. This will be the first time that a spacecraft from Earth has approached a comet and passed close to its nucleus. The Soviet Union and Japan, too, have a rendezvous with the comet. It is significant, surely, that Europe will be there at this historic meeting out in space.